Hello everyone, welcome to our sessions. In this series of videos, we are going to cover 9 chapters of Pure Mathematics 1. Chapter 1 is Algebraic Expression. We will cover Surds and Rationalizing Denominator in this video. We will be going through each topic with examples and some book exercise questions step by step. We will be also discuss some tips on how to avoid making mistakes so you can excel in Excel. Let's start our journey. Topic is 1.5 Surds. To understand Surds, first we have to understand what do you mean by rational number and what do you mean by irrational number. So rational number you can write in form of P over Q, and in decimal that are reoccurring and terminating decimal. For example, 5 over 4, 2 over 3, 1.25, etc. Irrational number you cannot write as a P over Q form, and they are non-terminating and non-reoccurring decimals. Means the decimal expansion of a surd is never ending and never repeats. This number we are telling is an irrational number. Example, root 2. If you put in a calculator, you will get numbers on and on. Other examples are root 19, 5 root 2. So surds are example of irrational number. To manipulate surds or to simplify surds, we are using these rules. First, root AB is equal to root A times root B. So if I have a root 6, I can write a root 3 times root 2. If I have a root 5 over 3, I can root 5 over root 3. This will help us for the simplification. Exercise 1E, simplify. We are going to do question M. 3 root 80 minus 2 root 20 plus 5 root 45. As you can see here, inside square root, numbers are different. So first we have to convert this number into same surd form. For example, root 80, I can write 16 times 5. There are so many factors, but I choose 16 times 5 because 16 is the greatest squared number we can have it, and square root of 16 is equal to 4 root 5. Root 20, 4 times 5, root 4 is 2, so it's 2 root 5. Root 45, 9 times 5, square root of 9 is 3, so 3 root 5. Now you can see here all the surds are in a root 5 form. So we can substitute this here. So 3 into 4 root 5. So instead of root 80, I substitute 4 root 5. Minus 2, 2 root 5. Plus 5, 3 root 5. Okay. Multiply bracket, 12 root 5 minus 4 root 5 plus 15 root 5. Everything in a root 5 form, so we can add and subtract. We will get 23 root 5. So this is our final answer. Question 2, expand and simplify if possible. As you can see, 2 brackets are there. So we have to multiply. So 2 multiply 3 minus root 7 minus root 3 multiply 3 minus root 7. 2 multiply by 3, 6 minus 2 root 7 minus root 3 times 3 will give you 3 root 3, and minus minus plus root 3 times root 7 will give us root 21 because we can multiply them. Now there is no like terms are here, so this one is our final answer. Now move to the next question. Question 3, simplify root 75 minus root 12 and give your answer in form of a root 3. So here we know we need surds root 3 here as our answer. So try to convert root 75 in a form of root 3. So I can write it down, 25 times 3 will give me root 3. And I know root 25 is 5 root 3. Root 12, 4 times 3, 12. and root 4 is equal to 2, so root 3. So first simplify this. Now put as a question. So 5 root 3 minus 2 root 3. That will give us 3 root 3. So this is our answer in form of a root 3. So this is our final answer. Next topic 1.6, rationalizing denominator. If a fraction has a surd in a denominator, we have to rearrange it so that the denominator is in a rational form, and that we are telling as a rationalizing denominator. We have to follow these rules. First rule is, if there is a 1 over root a, then multiply numerator and denominator by root a. So times root a over times root a. So root a times root 1 will give you root a, and root a times root a will give me a. Example, if 1 over root 3 is there, I have to times by root 3, multiply and divide with root 3. So that will give me root 3 over 3. Next law, if my fraction having a plus root b in a denominator, then I have to multiply numerator and denominator by a minus root b, opposite sign. Okay. For example, if I have a 1 over 5 plus root 7, so I have to multiply 5 minus root 7 and divide 5 minus root 7. In a numerator, 1 times anything will give you same, so it's 5 minus root 7. Denominator, you can see this is a plus b, a minus b. So it's a difference of square is there, so you can write a squared minus b squared. So I can write it down 5 squared minus root 7 squared. Because this is my a plus b, a minus b. So when I simplify denominator, 5 squared, which is 25, minus root 7 squared is 7. So 5 minus root 7 over 18. Second, if I have a denominator a minus root b, then I have to multiply numerator and denominator with a plus root b. For example, if I have a 1 over 3 minus root t, so I have to multiply 3 plus root 2, 3 plus root 2. So 3 plus root 2 over, again, difference square, which will be easy. You can multiply expanded also, but that will be easy. So 3 squared minus root 2 squared. So 3 plus root 2 over 9 minus 2. 3 squared 9, root 2 square is 2. So 3 plus root 2 over 9 minus 2, which is 7. Now let's move to exercise 1F. Question 1 is simplify. We are going to do question G. Root 12 over root 156. So 12 we know it's 4 times 3. And root 156, you can do factors of that. That will give us 4 times 3 times 13. Try to do the prime factorization. Now root 4 is 2 and root 3. Here in denominator 2, root 3, root 13. 2 get cancelled, root 3 get cancelled. So we will get 1 over root 3. Now, we can't put surds in a denominator, so we have to rationalize it. So I have to multiply and divide by root 13. So root 13 over 13. So this will be our final answer. If you write this as a final answer, then maybe you will not end up with the full mark. Next question. Question to rationalize the denominators and simplify. To rationalize, we know that we have to multiply opposite surd of denominator. So times by root 17 minus root 11 and root 17 minus root 11. Numerator, we have to multiply. We should consider this 2 as a 2 bracket. So we have to expand. So root 17 multiply with this bracket, root 17 minus root 11. Minus root 11 multiply with root 17 minus root 11. You can use this method, multiply by this, multiply by this, and multiply by this. And you can do this way as well. Bottom, we have to use difference of square. So root 17 squared minus root 11 squared. Root 17 times root 17, 17. Root 17 times root 11 will give you root 187 minus root 187. This and plus 11. Root 11 times root 11, which is 11. Bottom, 17 minus 11. 17 plus 11, which is 28, minus 2 root 187 over 6. You can further simplify because you can see in the top there is a 2 is a common factor. So 14 minus 187 over 6. 2 divided by 6 will give you 3. So 14 minus square root of 187 over 3. This is our final answer. Move to question number 4. Simplify 3 minus 2 root 5 over root 5 minus 1, giving your answer in form of p plus q root 5, where p and q are rational numbers. So this is also rationalizing denominator, but we have to convert last answer in this form. So 3 minus 2 root 5 over root 5 minus 1. To rationalize, multiply with root 5 plus 1, root 5 plus 1. So again, expand this 2 by multiplying. 3 into root 5 plus 1 and minus 2 root 5 plus 1 over root 5 squared minus 1 squared. So this is 3 root 5 plus 3 minus root 5 times root 5 will give 5 times 2, which is 10, and minus 2 root 5. Bottom, 5 minus 1. 3 root 5 minus 2 root 5 will give you root 5, plus 3 minus 10 will give you minus 7, and 5 minus 1 will give you 4. But we need in a p plus q root 5 form. So we have to make the denominator separate. So root 5 over 4 minus 7 over 4. But we need root 5 in a second, so we can rearrange it. So minus 7 over 4 plus root 5 over 4. And as you can see, p and q are rational numbers. So here 7 over 4, which is your p, and 1 over 4, it's your q. So this is the final answer for this question. Let's move to past paper questions. For the past paper questions, question fx is equal to x plus root 2 whole squared plus 3x minus 5 root 8 whole squared. Because it is square, so we have to expand them. So I can expand x plus root 2, x plus root 2. So when I expand x into x plus root 2 plus root 2 into x plus root 2. You can multiply this way as well. How you feel comfortable. So it is x squared plus root 2x plus root 2x plus 2. So x squared plus root 2x will give me 2 root 2x plus 2. This is the simplification of this part. Now we've simplified this part. For that, 3x into 3x minus 5 root 8 plus, sorry, minus is there, 5 root 8 into 3x minus 5 root 8. So I multiply first term in bracket, second term in bracket. So 9x squared minus 15 root 8x minus 15 root 8x minus minus plus 5 times 5 will give me 25. 25 times root at 8 will give me 200. Further simplify because you can add this term. 9x squared minus 30 root 8x plus 200. So this is the simplification for the second. Now I am putting in a form of a fx altogether. So x squared plus 2 root 2x plus 2 plus 9x squared minus, now here I can convert root 8 into root 2 form because I have a root 2 here. So we know that root 8 is equal to 4 times 2. That will give me 2 root 2. So here 30 and I am writing 2 root 2x. So instead of root 8, I write 2 root 2x plus 200. Okay, so we can simplify it further. X squared plus 10x squared will give us 10x squared. Now minus 30 times 2, which is minus 60, and this is plus 2. So this will give us minus 58 root 2x. 200 plus 2 will give us 202. Now we have to compare our answer with this ax squared plus bx root 2 plus c. So as you can see here, this is our a, b and c. So a is equal to 10, b is equal to minus 58 and c is equal to 202. Next question, solve this equation. Solve means we have to find value of y. First expand bracket. So root 3 times 4 will give me 4 root 3y minus 3, and root 3 times root 3 will give me 3. So 9 is equal to 5y plus root 3. I will take this y term this side, so I can take y common. So 4 root 3y minus 5y is equal to root 3. Minus 9 will move this side, will give me plus 9. Y is a common. 4 root 3 minus 5 is equal to root 3 plus 9. So y is equal to root 3 plus 9 over 4 root 3 minus 5. But we need our answer in a simplest form. So we have to rationalize it. For that, I have to multiply numerator and denominator with 4 root 3 plus 5, 4 root 3 plus 5. Now multiply numerator by expanding bracket. So y is equal to root 3 multiply with 4 root 3 plus 5 plus 9 multiply 4 root 3 plus 5. So this will give us 4 root 3 times root 3 will give us 12 plus 5 root 3 plus 36 root 3 plus 45 over 4 root 3 squared minus 5 squared. Here also you can write denominator. 12 plus 45 will give us 57 plus 41 root 3, 4 root 3 squared. 4 square is 16, root 3 squared, which is 3, which will give us 48 minus 25. So 57 over 23 plus 41 over 23 root 3, because we need our answer in P and Q form. So that's our answer. So r minus 1 over r minus 1 over r times r will give r squared, r times 1 over r1 will cancel minus 1. This also give us minus 1 and plus 1 over r squared, minus and minus will r squared. Further simplified, minus 2 plus 1 over r squared. That's our expansion. B, express this surd in form of p plus q root 2. So we have to rationalize it. So 3 plus 2 root 2 times by 3 minus 2 root 2, 3 minus 2 root 2. So Numerator 3 minus 2 root 2. Denominator 3 squared minus 2 root 2 squared. So 3 minus 2 root 2 over 9 minus 2 squared 4 and root 2 squared 2, which will give us 8. So 3 minus 2 root 2, 9 minus 8 is 1, so we are not going to write it down. So this is our final answer in form of P plus Q root 2. So this is your P and this is your Q. Part C, use the result of parts A and B. So I already written here. Or otherwise show that this is equal to 2. So what I am doing it, I am assuming this question is a y. So y is equal to square root of 3 plus 2 root 2 minus 1 over square root of 3 plus 2 root 2. Now I have to use this result. So I am doing a square both side. So y squared is equal to, this is my r. So what the expansion? So r squared. So when I'm doing square of this term, the square root will remove. So that will give me 3 plus 2 root 2 minus 2. And expansion of 1 over r squared. So plus 1 over 3 plus 2 root 2. Now can you see similarity for this part and B part? So I already rationalized in a B part. This is my rationalization. So I can substitute this here. So 3 plus 2 root 2 minus 2 plus 3 minus 2 root 2. So simplify. 2 root 2 will get cancelled. 3 plus 3 will 6 minus 2. So y squared is equal to 4. So do square root for both sides because I need y, which is equal to 2. So I proved my y is equal to 2. So this is our answer. Next question. Write 8 minus root 15 over 2 root 3 plus root 5 in form of a root 3 plus b root 5, where a and b are integers to be found. Again here we have to rationalize. So 8 minus root 15 over 2 root 3 plus root 5 times 2 root 3 minus root 5 and 2 root 3 minus root 5. So top part, I have to expand bracket. So 8 into 2 root 3 minus root 5 minus root 15 2 root 3 minus root 5 over 2 root 3 squared minus root 5 squared. Expand bracket. 16 root 3 minus 8 root 5. Root 15 times root 3, which is root 45. So minus 2 root 45 minus plus root 75 over 4 times 3, 12 minus 5. Now we have to convert root 45 and root 75 into simplest form. So we know root 45 is equal to 9 times 5 will give me 3 root 5 and root 75, which will give me 25 times 3, that will give me 5 root 3. I will substitute here. So 16 root 3 minus 8 root 5 minus 2 times 3, which is 6 root 5 plus 5 root 3 over 12 minus 5, which is 7. 16 root 3 plus 5 root 3, that will give me 21 root 3 over 7 minus 8 minus 16 will give me minus 14 root 5 over 7. Why I did? Because I need answer in this form. 21 divided by 7 will give me 3 root 3 minus 2 root 5. So this is our answer in form of a root 3 minus or plus b root 5. So a is equal to 3 and b is equal to minus 5. So this is our answer. Part B, hence or otherwise solve this equation. When they are telling hence or otherwise, we have to use the part A result. So I already written here. So when we are finding in a simplest form, So first I have to expand this bracket. So root 5x plus 5 root 15 is equal to 40 minus 2x root 3. I am taking this other side because I need all x on one side. So 5x plus 2x root 3 is equal to 40 minus 5 root 15. Take x common, so root 5 plus 2 root 3 is equal to 40 minus 5 root 15. So x is equal to 40 minus 5 root 15 over 2 root 3 plus root 5. I rearrange it or I just swap it because it's addition, so it doesn't make any difference. Now I have to use this result. So I can see in a denominator there is something I can factorize. 5 is a common factor. So 8 minus root 15 over 2 root 3 plus root 5. So now I can substitute this value instead of this whole question. So 5 into 3 root 3 minus 2 root 5. Multiply, which is 15 root 3 minus 10 root 5. So this is our answer in a simplest form. Okay, important takeaway for this topic is multiply same surds will give rational number inside surd. So for example, root 5 times root 5. So that will give me 5. So basically we can write root 5 squared, and square and square root will get cancelled, so we get 5. What happened? We have a root 5 cubed. So in that case, I can write root 5 times root 5 times root 5. So this root 5 times root 5 will give me 5, and I can't simplify it further, so that will give me 5 root 5. So when you simplify, take care of this thing. You cannot add or subtract different surds. For example, if I have a root 5 plus 2 root 3, I cannot add them because this is root 5, this is root 3. But if I have a root 5 plus 4 root 5, so I can add 5 root 5 because 4 plus 1 will give me 5 root 5. But we can multiply different ones. For example, I have a root 5 times 2 root 3. So I can write 2 root 15 because root 5 times root 3 will give me root 15 and 2 is there. So this way we can simplify it. Rationalize surd always use a difference of 2 squares for to simplify denominator. For example, I have a 3 plus root 2. So we know for rationalizing I have to multiply with the opposite sign. So 3 minus root 2, 3 minus root 2. So numerator stays same because times by 1. But the denominator simplify, we have to assume it's a and b. So this is a plus b and this is a minus b. So I can write a squared minus b squared. So 3 minus root 2 over 9 minus root 2 squared 2, because we know here root 2 squared is 2. So 3 minus root 2 over 7. When you will use this one, this make your simplification easy. You can expand it by multiplying, but this one is easy. Thank you for watching this video. If you find this video helpful, please give it thumbs up. Do subscribe for more math content and let me know in the comments if you have any questions or topics that you would like to see next.